Hi guys, today we're going to talk about time complexity. This is very much important in any of the interview questions. So for any better solutions, we always have to find out the time complexity and space complexity. So to any problem, if you bring the solution of O of n, O of 1, so this is the best solution that you can bring it to the problem. And if you're bringing a log n, so log n is also very good, and till this n, so it is always found as a good solution. And if it is like n square and n3, which you should never target, n3 would come here, somewhere in here. So we should never target for those time complexities. Always try to be below this n square. Try to be like n log n to this O of n, depends on the problem. If it is like really you have to do some kind of sorting, then you always have to end up in n log n. So otherwise, in for any other search, it's better to find it in the log n complexity. So this is the time complexity. So let's talk more about that. Okay, so what is this n? How we are finding that time complexity would like O of 1 or n? So what is that? So let's see, take an example of array. If this is an array, if you have to find an element of 6, if it is a linear search, then you have to go one element, the other element. You start with 0, check if it is 0 element 6, no. If the second element is 6, no. Third element is a target element 5, 6, right? So we came to know this last element is what? The target element. So if that the target element, then we're going to return. So by this, if you see, you have touched every element in this array. So which is a n number of elements. So in that case, the time complexity would be O of n. What about this binary search? So what is this binary search? Binary search is nothing but like same array if you take it. So if you want to find an element of 6, so we would find the mid element, and if see if this mid element is greater than 3, then divide this into an half array. So this is a like logical separation. So you're not creating any new array here. So search it from this 4 to 6, and again you just do one more logical separation, and find the mid element of 5 and check if it is greater than the mid element, then search it on to the right. So if you see it on every single iteration, you're dividing the array into a half logical separation, and you're trying to find an element. So if you see, we have found the element 6 in just two iterations, two operations, otherwise not iterations. In two operations we have found this 2 in the element 6, but here if you find it, we have went all through the elements. So n operations, right? It took n operations here, it is only 2 here. So what this 2 constitute is, so is like 2 power of k equal to 6. So this k is what? Log n we call it as. So what brings the k to make it 6 is like 2 power 2, right? It is not 3. 3 means it's 8. So almost near to 2, it brings is like 4. It is like approximate. We are not talking about the exact number. So it's approximately tends to 6. So that's what we are bringing here. It's 2 operations. Within 2 operations, we are able to find the element which constitute log n. Okay, so now come back to this hash map. So in a hash map, whenever you want to find an element, just give the key and you would return that element. This is a constant timeout. So you always have to like if you have the hash map in your mind, and you want to implement for any of the problems, that is the best solution that you can bring in. And try to use more of the hash map in any of the problems, so which would return you the O of n time complexity, which is the best solution that you can come up with. Okay, and this is retrieve an element from the hash map, because you're just giving a key and it's going to return a value. Okay, so in linked list, if you want to search an element, So then you have to go, because we have something called here head. So you have to move this pointer head and then check where the element is. So here for the linked list, the time complexity is always O of n, because you have to do a linear search, right? You cannot do a binary search in the linked list. So for that, the any element you have to search it in linked list, then it is always O of n. So trees. Tree is a special case. If you want to search an element, like if you want to search an element of 20, what you do? You come to this root. This is the root, and check if it is greater than the root. Yes. Then you go on to the right and you check again the second. This is now root. So if it is greater than 15, yes. So you go on to the right and if you check this element. So if you see here also, you just in two operations we found the element, right? So the root also constitutes like log n. So that's a very good time complexity. So whenever a problem is given to search something, you can always see, okay, tree is good options that you can think of, hash map is very good options, and then the binary search. So this is all the problem. And what about this n log n is nothing but sorting. So we'll talk about sortings in other videos. I hope this is easy to understand. Thank you, guys.